Bismillahirrahmanirrahim. Assalamu alaikum dear students, how are you? I hope you'd be fine. This is Quadrilaterals chapter number 5, and in this video we are going to talk about how to identify quadrilaterals, what are quadrilaterals, how can we describe them, how can we classify different sort of quadrilaterals, what are their types, what are their characteristics and all. So let's begin with the basic definition of quadrilaterals. Quad means four, as you people would have learned about it as quadruplets, like four babies who are born at the same time are called quadruplets. Okay, similarly when we talk about the Cartesian plane, so this is x-axis, this is y-axis, and it has four quadrants. So every word that has quad in the beginning means four. Okay, and the word lateral means the sides. So quadrilateral means any shape, any figure having four sides. So as the name suggests, you must come up with different examples. You must have heard of the square and a rectangle and a parallelogram. Similarly, we have rhombus and then a kite and then isosceles trapezium or trapezoid or these sort of figures. So these are all the figures which have four sides each, four sides and four angles each, and so they are all quadrilateral. So we can easily identify any shape as a quadrilateral if it has four sides. Okay, and I have told you some names of these shapes as well. Now we'll try to understand all these quadrilaterals with the characteristics they all possess. So open up page number 69. We are provided with some of the quadrilaterals over here and along with the characteristics written over here. So we are going to figure out that what characteristics are found in which of the quadrilaterals. So starting from the first one, four equal sides. So here we have a few figures. If we talk about a square, so in a square all four sides are equal. Okay, but in a rectangle, no, not all four sides are equal, only the opposite sides are equal. Okay, so this characteristic is not found in rectangle nor in a parallelogram. So the characteristic of having opposite sides equal is found in rectangle and in parallelogram, right? That is, the opposite sides are equal. But the characteristic of having all four sides equal is found in one more quadrilateral, and that is rhombus. All four sides are equal in a rhombus as well. Okay, so we can say that in a square and in a rhombus all four sides are equal to each other. Apart from that, in none of the other quadrilateral all four sides are equal. Next we have two pairs of equal sides. Two pairs of equal sides means the opposite sides are equal. Okay, so here, no, now we have found that in a square and in a rhombus opposite sides are also equal and all four sides are equal. So we are not supposed to tick this one here, we'll cross it. Okay, because here this characteristic will be followed. Same in the rhombus. Next we have rectangle. So yes, we have one pair and the second pair has two, the opposite sides are equal, so it has two pairs, one pair and the other pair. So in a rectangle opposite sides are equal, in a parallelogram the opposite sides are equal. And then we talk about the isosceles trapezium. So in an isosceles trapezium also we have one pair of equal sides. Oh, okay, so this characteristic is not follows in isosceles trapezium because we have only one pair of equal sides, not two pairs of equal sides. Okay, you can see that this side is shorter and this one is longer. So in an isosceles trapezium we have only one pair of parallel sides. So this characteristic is found in two pairs of equal sides in a rectangle and in a parallelogram. They have already marked it as tick. Okay, and apart from this, in a trapezium, in an isosceles trapezium and a kite, no two pairs of equal sides are found. Then the third characteristic says one pair of equal sides. We just discussed it. Which of this quadrilateral has one pair of equal sides? So that's isosceles trapezium. Apart from that, none other figure has one pair of equal sides. So we'll cross all the other. Next we have one pair of parallel sides. Okay, what does parallel means? Parallel means the two lines we make two lines just like the railway track. They have the same distance all along, are called parallel lines. So these two lines are not parallel because they will, if we'll extend the two lines, they'll meet at a point. So the two lines are said to be parallel if they do not meet at any point, no matter how long we extend them forward or backward. They will have the same distance between them, and the best example for parallel lines is the railway track. Okay, so here we have to figure out that in which of these quadrilaterals we have one pair of parallel sides. One pair of parallel sides. So it's again the isosceles trapezium. We have one pair of parallel sides. These two lines are parallel, and one pair of equal sides. Equal and parallel are two different things. Equal means equal in length. Parallel means having same distance between the two lines. So in only isosceles trapezium we have one pair of parallel sides. Apart from that, we have two pairs of parallel sides in a square, in a rectangle, in a parallelogram, and in a rhombus. In all these four figures we have two pairs of parallel sides. So when we talk about one pair of parallel sides, it's only found in isosceles trapezium. That's all. Okay. The next characteristic says two pairs of parallel sides. So as I told you that the opposite sides are parallel to each other in a square. These two are parallel, and similarly these two are parallel. And so in a rectangle, these two are parallel. These two lines are parallel. Similarly, these two lines are also parallel to each other. They have the same distance along them. Similarly, in a parallelogram, these two sides are parallel, and then these two sides are also parallel to each other. Okay, and then in a rhombus also the opposite sides are parallel to each other. Okay, so we can say that we have two pairs of parallel sides in a square, in a rectangle, in a parallelogram, and in a rhombus. Not in a trapezium, nor in isosceles trapezium or a kite. Okay, next we have all angles 90 degrees. So when we have two lines perpendicular to each other like this, okay, there is an L or an inverted T, so this is called a 90 degree angle. Okay, the two lines are said to be perpendicular when there is a 90 degree angle between them. So all the angles are of 90 degrees in a square. 90 degrees, 90 degrees, 90 degrees, 90 degrees. Similarly, in a rectangle we have 90 degree angle, 90 degree angle, 90 degree, and then 90 degree. Okay, apart from these two figures, in none of the other quadrilateral we have angles of 90 degrees. Here you will find that it is less than 90 degree. This one is more than 90 degrees. But in this figure we have the opposite angles equal to each other. These two are, if this is x, this is also x. Like if this is 40, this is 40. If this is 45, this is also 45. Okay, and if this is like 100, so this one is 100. If this is 120, this one is 120. If this is 140, this one is 140. But in a rectangle and in a square, only in these two quadrilaterals all angles are of 90 degrees each. So all angles are 90 degrees in a square and in a rectangle, right? And then one pair of equal angles, only one pair of equal angles. So it's just a kite in which we have only one pair of equal angles, this one and this one. Okay, so these two angles are equal each. Apart from that, these two angles are not equal to each other because we have these two sides equal to each other and these two sides are equal to each other. Okay, so that's why we have only one pair of equal angles in a kite, not two pairs of equal angles. So one pair of equal angles are only found in a kite. Okay, then we have two pairs of equal angles. In which of these figures we have two pairs of equal angles? Okay students, we missed one thing over here when we talked about one pair of equal sides. So it was just a rhombus, and isosceles trapezium. But when we talked about two pairs of equal sides, so it's not just rectangle and parallelogram. In a kite, we have two pairs of equal sides as well. Like these two sides are equal to each other, one pair, and the other pair is also equal to each other. So in a kite also, we have two pairs of equal sides. So tick mark here. Okay, just make a correction. We have two pairs of equal sides in a kite as well. Now let's talk about the next characteristic, which says two pairs of equal angles. So we have two pairs of equal angles. We have all angles are equal to each other in a square and a rectangle, so we'll mark them across. But in a parallelogram, I told you that we have one pair of equal angles, like if one is y, the other one is y. If one is 100, other one is 100. So this is one pair of equal angles, and these two are again equal to each other. So opposite angles are equal to each other in a parallelogram. And then in a rhombus, again the opposite angles are equal to each other, and none of the angles are 90 degrees in a rhombus. That's the difference between a square and a rhombus. All four sides are equal in a rhombus, but not all four angles are equal. Okay, so in a rhombus, only opposite angles are equal to each other. None of the angle is 90 degree. Unlike a square, in a square all four angles are 90 degrees each. But yes, if one of the angle is, let's say, 100, so this one is also 100, and then these two angles are supplementary as well. Like if one is 100, the other one would be 80, because supplementary means the angles having a sum of 180 degrees. When we will add these two adjacent angles, it must be 180. So if one is 100, the other one must be 80, and the opposite would also be 80. So we have a parallelogram, a rhombus, where we have opposite angles equal to each other. So we have two pairs of equal angles in a parallelogram and in a rhombus. Okay, right? And next one is a bit tricky. It says diagonals bisect each other. Diagonals bisect each other means when we will draw lines, diagonal lines over here, okay, these two are diagonal lines. Okay, bisection means when I will draw these two diagonal lines, they will cut each other into equal parts. Like the length of this line will be cut into two equal parts. This part would be equal to this part. Like if the length from here till here it's 5 centimeter, so the length from here till here would also be 5 centimeters. If this diagonal line would be 10 centimeters, then this half would be 5 centimeters, and this one would also be 5 centimeters. This is what it means by that a diagonal line will bisect the other diagonal. Similarly, this diagonal will bisect this diagonal, and this diagonal will also bisect this diagonal. Like if this one is also 10 centimeters, so this one would become 5 and 5 centimeters. Okay, same thing happens in a rectangle. Like when we will draw a diagonal line from here, and let's say it is of 12 centimeters. So when we will draw another diagonal line, so these two would be equal to each other. This one would be 6 centimeters, 6 centimeters, 6 centimeters, 6 centimeters. This is how they bisect each other. Similarly, if we talk about in a parallelogram, when we will draw a diagonal line over here and another diagonal line opposite to it. So let's say this line is 4 centimeters, for example. So this one would be 2 centimeters from here to the center, and from the center to the end it would also be 2 centimeters. And if this line is, let's say, 6 centimeters, so this one would be 3 centimeters from here of the edge to the center, and to the center to this edge it would also be 3 centimeters. This is what it means by bisecting the diagonals. Okay, so if we draw the two diagonals, they will bisect each other. This also happens in a rhombus. Okay, so in a rhombus also the diagonals will bisect each other. And also in a rectangle, one more thing happens, that the angles are of 90 degrees each. Okay, none of the angles at the corners are 90 in a rhombus, but the angles that are made by the two diagonals would be 90, 90, 90, 90. Okay, And if we talk about here, we will draw this diagonal line and another diagonal line, right? So if this line is, let's say, 4 centimeters, then this will be bisected. This one would be 2 centimeters and this one would be 2 centimeters from the edge to the center to the edge. But if we talk about this diagonal line, this is not bisected. As you can see, this is the center. If let's say this is having a length of 9 centimeters, so this is just 3 centimeters, and this one would be the double, that is 6 centimeters. So you can see that in a kite, only one diagonal line, only this diagonal line bisect this one, but this diagonal line does not bisect this one. So we can conclude that in a square, in a rectangle, in a parallelogram and a rhombus, the diagonal lines bisect each other. Okay, so square, rectangle, parallelogram and a rhombus. In these figures, the diagonals bisect each other. Apart from that, diagonals meet at 90 degrees. Okay, and if we talk about diagonals bisect, only one diagonal bisect the other. This characteristic is not given, but you must know that in a kite, only one diagonal bisect the other. Okay, and then let's talk about the diagonals meet at 90 degrees. So we learnt about it. Here in this angle, diagonals meet at 90 degrees, 90, 90, 90, 90. So this happens in a rhombus. And then in a square, I think the diagonals also meet at 90 degrees. But this does not happen in a rectangle, since this angle would be greater and this one would be smaller. So this only happens that diagonals meet at 90 degrees each in a square and in a rhombus. Apart from that, in none of the other quadrilateral, diagonals meet at 90 degrees. So it's just a square and a rhombus. Apart from that, in all of these, diagonals meet at different angles, not at 90 degrees. Wait students, when we talk about diagonals meet at 90 degrees, so this also happens in a kite as well, that the diagonals meet at 90 degrees each in a kite. So it's a tick over here in the last one. In a kite, like the three figures have diagonals that meet at 90 degrees each. That's a square, a rhombus and a kite. And when we talk about two pairs of equal angles, so like a parallelogram, two pairs of equal angles, this property applies in a parallelogram. Also in an isosceles trapezium, we have two pairs of equal angles. How? Let me show you. Here we have an isosceles trapezium. Since we have two of the sides equal to each other, therefore these two angles are equal to each other, right? And similarly, the two angles below are also equal to each other, right? Like if one of the angle is, let's say, 120 degrees, so this one would be 120 as well. And similarly, if this one is 80, so sorry, let's say if this one is 60, because the sum of the two angles must be supplementary 180. Okay, so if this is 120, this must be 60. But these two angles would be equal to each other because of these two sides being equal to each other. That's all. Okay, and since these two lines are parallel at the same distance, therefore this happens that we have two pairs of one pair, another pair of equal angles. So yes, this is also a tick over here. We have two pairs of equal angles in an isosceles trapezium and in a rhombus. Okay, so we have three figures where we have two pairs of equal angles, a parallelogram, an isosceles trapezium and a rhombus. And then there was one more thing to discuss here when we talked about one pair of parallel sides. So we have one pair of parallel sides in both a trapezium and an isosceles trapezium. Okay, one pair of parallel sides are found in both a trapezium and isosceles trapezium. When we talk about one pair of equal sides, so it's just an isosceles trapezium where one pair of equal sides are found, but in both trapezium and isosceles trapezium we have one pair of parallel sides. That's the characteristics of a trapezium only, where we have only one pair of parallel sides. Okay, because apart from that, this characteristic is not found in any other quadrilateral. Okay, so one pair of parallel sides are found in both a trapezium And this is the only characteristic that is found in trapezium, because we have none other characteristic that is found in trapezium. No four equal sides, no two pair of equal sides, no one pair of equal sides, no two pairs of parallel sides, no angle of 90°, no pair of equal angles, no two pair of equal angles. So we have no characteristic found in trapezium apart from this one, right? So this was a mistake over here. Just make correction that in a trapezium we have one pair of parallel sides, like an isosceles trapezium where we have one pair of parallel sides. So it's a tick over here. That's all. Okay. So we have learned about these quadrilaterals in detail in this video. I hope you liked it. If you liked the video, please share it with your friends, and subscribe to my channel if you are new, and take care. Allah Hafiz.